Right, so we're going to be walking through one proof together today. Just keep in mind when it comes to the proof for these ones, we will go over these types of proofs in a little more detail, but just going to walk through this one to see why it is that when you add all these angles together inside of a triangle, that it's always going to equal 180 degrees. So here we go. So first statement says draw PR through R parallel to AC. So the main key part that you have to know about this proof is it's already stating that those lines are going to be parallel to each other. So keeping that in mind, you can draw the arrows here if you'd like to show that or to remind yourself. But that's the key part that they're going to be using in this example. So it says PBC and angle 3 are supplementary. So let's take a look. It says PBC, so 1 and 2 added together here, and 3 are going to be supplementary. So we know this because it makes a straight line. So we can say definition of a linear pair, or you can mention something about supplementary angles. Either one is going to work. So again, multiple ways you can approach it. So it mentions angle PBC plus measure of 3 is 180 degrees. So stating the same kind of thing. It's saying when we add these two together, they're 180 degrees. So you can say definition of supplementary angles. So you can even make a note, add to 180 for anything dealing with a line. So then it mentions that angle PBC is adding 1 and 2 together. Well, we can already see that up here in the diagram, that 1 plus 2 here will equal that entire angle. So this is our angle addition postulate, adding 2 parts to create the whole part. So then it states M1 plus M2 plus M3 is equal to 180. So it may seem a little bit strange because it's almost like it skipped a step, but 3 and 5 are stating the same thing. PBC is the same thing as adding 1 and 2 together. So it's substituting itself in. So you can say substitution or transitive property of equality. So again, if you forgot some of these properties already, don't worry. We're just going to walk through this one together, and we will look through some of the more definitions and proofs to get more accustomed to it. So angle 1 is congruent to angle A, and 3 is congruent to angle C. Well, let's see why they say that. It says 1 is congruent to angle A, so 1 and A they're saying are the same, and then 3 and angle C they're saying are the same. Now part of the reason is because these are actually transversal lines. Here you have 2 parallel lines and you have a line that's cutting through. So if this is our interior, so everything in between those 2 lines, 1 and A are going to be alternate interior angles. So we are going to state that they can be congruent because of alternate interior angles are congruent. Again, only true if there's parallel lines, but they already stated earlier that those lines were going to be parallel to each other. So if you're wanting to know, okay, so what has changed, aside from dealing with more triangles, that's really our only new step. All these other ones we've talked about so far. So that states 1 is equal to A and 3 is equal to C. Now, they already are restating this. The only thing that happened was the signs changed. So we can say it's the definition of congruent angles. All that happened was the change of the sign just to state the same thing. So last but not least, for our final step, all we're doing here is we're plugging things in. We know 1 is equal to A, 3 is equal to C, so they're using step 5 to plug these in to show and prove that adding those 3 together, or the interior angles of our triangle, will give us 180 degrees. So plugging in means substitution, or you can say transitive property. All right, there you go. There's our proof. And so we're going to move into number 14, and then we'll talk about 15 and 16 together and just a couple more examples from there.